Assalamualaikum and a very good morning to all. So today I would like to share my progress on my study in numerical investigation of TVOC and PM2.5 in indoor environment of vessel at harbour and during sailing condition. So my name is Nazeefah binti Muhammad Sharif and I'm being supervised by Associate Professor IR in Senior Technologies Dr. Azli bin Abdul Razak and Dr. Muhammad Faizal bin Muhammad. So, the introduction is there's a need to measure and define a quality standard for those working in confined space, especially within a vessel. The crew member, this is because the crew members spend so much of their time in a vessel. With a high temperature and humidity level increase, the level of contamination of indoor air. This poor indoor environment could lead to many health problems, including allergic reaction, respiratory problems, eye irritation, sinusitis, bronchitis, and pneumonia. So there are few factors that contribute to the IAQ inside a vessel, which is mostly stated low air exchange rate in the cabins, insufficient ventilation, all and all vessels tend to spread microbial pollution due to the maintenance problem. And then internal practices such as smoking, cooking, producing electricity, biological and chemical emission, which is give direct impact on enclosed space. So we take a look. This is the health effect of formaldehyde, Betex, and PM2.5 is a long-term health effect. So this is the factors that contribute to IAQ, which is the exhaust, the insufficient ventilation in the engine room, the internal practices, cooking in the galley, the tiny spaces, and the the most right one is the MCR. Well, as you can see, the problem statement is the period spent on board are relatively longer than other transportation mode, which vessel is defined as a transport that have accommodation, cabins, kitchen, and toilets for crew passengers. IQ on a ship may be worse due to the highly airtight spaces formed in the watertight bodies. Level of dissatisfaction with the indoor and air thermal environment is higher than the other environmental factor. So, Kim and Lee also reported that level of CO, CO2, and PM10 in the engine room are above the limit. That's why we are going to focus our study on the engine room. TVOC concentration range from 10 to 70, 60 gram per meter cube, but formaldehyde concentration were lower than 50 milligram in Kim's and Lee's paper. And currently, Malaysia Maritime Enforcement Agency is in the midst of asset deposition and replacing with a new one. So we hope by this study it could be an improvement towards the new vessels of MMEA. So this is the galley and GRC. This is the watertight doors. So the important parameters of IAQ is we can divide it into three, which is physical parameters, chemical parameters, and biological parameters. This is the IAQ standards for vessels that happens to have today, um, that we are going to use in our study, which is by DOSH 2010, ABS American Bureau. Uh, we're going to set with WHO, and we have for vessel in Korea they have a IAQ Act, and we also few for CO2 and PM10. We are going to compare with ASHRAE. So the question and objective for this study is, the main aims of the study is to assess the TVOC and PM2.5 compound inside a vessel and its contributing factors. So as you can see, there are five research questions, which is, what is the level of TVOC and particulate matter inside the vessel? What is the correlation of TVOC and PM2.5 compound with the age of the vessel? The research question number three, does the IQ in a vessel increase during the sailing compared being at harbour? And what is the correlation of concentration of TVOC towards size of compartment? And the last one is, what is the thermal comfort level inside the vessels? So within the research question, there are four research objectives. First is to investigate the concentration of TVOC and particulate matter inside the vessels. Second is to investigate the concentration of TVOC and particulate matter during sailing and static condition. The third one is to develop correlation of microclimate environment and the IAQ. And the last one is to evaluate the flow pattern inside compartment in a vessel and its effect towards CO2 through CFD simulation. So this is the scope, research, and limitation. First, we are going to do research on MMA vessels, and it can vary within the type, the size, and the age. The studied parameter will be temperature, ambient humidity, CO and CO2. Methods of data collection is direct reading using direct reading instrument, which is environmental monitoring instrument, gas tracer, thermal environmental monitor, and thermal recorder. The condition for the vessel is during at a harbour and cruising. So this is the research framework. This is the targeted vessel that will be, this is the OPV, the KM Pekan, KM Langkawi, and KM Tun Fatimah. KM Tun Fatimah will be the newest vessels. So basically, we are going to study on NGPC class, which it has 6 vessels. So the significance of this study is, first, to expand knowledge regarding IQ inside the vessels. It is important as the period spent on board are relatively longer compared to other transportation. The growing body of knowledge on IQ and the potential contaminants exposure in the sea transportation in Malaysia is also to provide significant factors that influence IQ characteristic in a vessel, which impact the health and productivity of the vessels. The output from the research can be applied in improving the understanding mainly on the behavior of air in associated with ventilation and design of compartment in the vessels. To also develop intervention strategy to better IAQ through identifying significant factors that contributing to adequacy of indoor, help control the source of pollutant, to improve the performance of ventilation, regulating parameters that influence good IAQ in the sea transportation. So there are few literature review I have done, and as you can see, the green one is the study in UITM in a car. The yellow one is a study in a vessel in Malaysia, and there are a few other papers. So as you can see, the study uh, in Malaysia, there are only three study in a vessel in Malaysia, and it has been done in a year 5 to 6 years back. So this is the gap study. As you can see, most of the studies shows that the the highest the highest TVOC compound is in the engine room. Okay. So we're going straight to the methodology that we are going to use. Um, yeah, so as you can see now, currently I'm in the phase three, which is I'm going to do my data collection this semester. Then I'll do the numerical simulation using the open form. So basically, this is the methodology, the direct reading instrument, and the vessel crew member perception survey, and after that CFD simulation in the critical compartment, which is that I chose is engine room. So this will be the instrument. This is the flow for the direct reading method, how to get the sample, and after that I'll be giving the IQ questionnaire to the cabin crew. So this is the questionnaire. Okay, as you can see, the highlighted places. This is for KM Langkawi. The highlighted places that will be done the study. But currently, I didn't um, design yet in the CFD. So for my Gantt chart, well, actually, I'm a bit behind schedule because should be I've been doing the on-site sampling already, but due to um, I need to calibrate my EMI, so currently I'm waiting for the device to be calibrated. Uh, I'll get it by the end of this month. So most probably in September